All right, we're gonna wait a little bit for the rest of everyone to jump into the room, but welcome to day 2 of Quick Pass. The last lesson we had on Monday, we had the Platoon team come in and kind of give introductions and overview of kind of what they do. Whether it be with admissions, with Greg, you talked to him quite a bit, or Tish, who deals with the VA benefits and admissions. And then we had Catherine talk about the career services. So all in all, like, I'm telling you, this is a great program. If you're serious about getting through the quick pass and getting a Platoon, this is a great program to get into software engineering and then have that support structure to get a job afterwards. There's no jobs are guaranteed, of course. There's a lot of factors when it comes to getting a job, but they are there to help you. You'll have a great community. We have a great alumni channel on Slack. And I already mentioned all this on Monday, but it just really opens doors. And then, of course, using LinkedIn, that's another big benefit in this field. You'll see jobs posted there, and then you can connect with anybody from Platoon on LinkedIn and build the followers. So it really is a good program, and so I urge you to stick through it. Quick Pass, again, this is a very it's a very formal lecture, but if you can't attend, that's fine. There's no attendance taken. There's no there's no requirements for you other than do the application and the live coding assessment. And doing these lessons will help you get there, because we have very distinct things we're measuring on that, and this course will cover those things in detail. And I'm going to invite Guillermo, who does the live coding assessment, to chat with the class next week. So I'll give him some time at the beginning, and he can kind of explain the whole process if you're not familiar with it, and then kind of give a bit more detail on what he's doing, or what he's measuring. On top of that, with Slack, again, if you have any questions at all, I'll accept, I'll answer a DM, but I really urge you to put questions in the main chat room so other people can see, because most likely someone's going to have a question like you. And no matter how basic it is, because this is a basic course, this is very foundational Python. So, I mean, any question about, I can't remember what a string is, like, what is that? Like, ask it, because we're going to answer, and we're not going to be mean about it, and someone may have the same question as you. So we also went over some problem solving strategies, so just how to think like a developer, how to break down a problem. Just keep those tools in mind when you're looking at some of these challenges, some of these examples we have, and they are useful to kind of think that way when you're breaking a problem down and then writing code to it. So just keep those in mind. Let me share my screen. And while I'm doing that, do we have any quick questions on any concepts or anything from last lecture that you maybe thought about afterwards, and you didn't want to ask in Slack? Is there any questions like that? Pull up the chat window, make sure I can see that. All right, can everybody see my screen?
Yes.
Okay, cool. Is it big enough, or do I need to change something?
Looks good.
All right, sounds good. All right, so day 2, we're going to talk about, again, this is very foundational, but we're going to talk about the Python native data types and methods. And the beauty of this is that this isn't just Python native data types and methods. This is going to be basically any data type and method that's native to any programming language. So these data types, when we're talking like strings or numbers, floats, and integers, they are recognized by any other, engineering language. And a lot of these methods are going to have very similar methods. They may have a different name, but they're going to have the same kind of methods in there. So, this is one of the advantages of learning Python, is it's easy to read, and that syntax barrier isn't very hard to cross. And once you understand those concepts with this data, it's easy to quickly learn the syntax if you already know the behavior. And so Python is a really good language to learn, programming in general. If you want to start diving into other languages, you can. So yeah, we're going to cover, the data types. We're going to cover, how to turn some data types into other data types. We're going to go over Booleans, numbers, some mathematical operators, some strings, go over the none type. And then we're going to get right into some exercises and some other additional exercises, the Replit challenges. So yeah, let's take a look at some of these data types. In this Jupyter notebook, we have some links here. These links will take you to the Python documentation or whatever other link I put in there. But I mean, this is a great way to kind of see from the source, from the python.org source, exactly what these things are. Sometimes they have a bit of technical jargon in there, but you can usually pick your way through it and see what they're talking about. So let's take a look at, let's find string real quick. I don't even know if it's in here. Let's see here, data types, string, here's string right here. This is like a string class. This will kind of define what a string is in a very basic sense. Sometimes a bit hard to read, but this will give you some basic information. And this is not the only source. I just put that source on there because it's coming directly from Python. You can also just Google Python string and get, W3 schools. You'll get a Wikipedia entry sometimes, and they'll give you kind of a more layman's term of what a string is. Or an integer or a list. So, but there are many data types in Python. We're just going to cover the basics in this lecture. So we're going to cover Booleans, integers, floating points. So both of those are numbers. We're going to cover strings and then none type. And here we have a table kind of showing what they're going to look like if you were to run the type method on them. So and we'll go over that as well. So, and the reason we have these data types is because they serve as like the basic way to manipulate data in the most I'm trying to think of the right word here, but the most customizable way possible. When we're talking about doing stuff with computers, you're really diving in there. When you're making something, you're making something from scratch. So it's like you can make a t-shirt on a website, right? And you can order a t-shirt and it'll already come out made. But when we're talking like learning coding, like it's like the same thing as like learning how to grow the cotton and then process it and turn it into thread and then actually put the shirt together. That's really the detail you're getting into. When you're actually learning coding, you're breaking things down to the very basic data types all the way down. And so and when you do that, these different data types, whether it's Boolean, integer, floats, they do different things in memory, and they look different to the computer in memory. And behind the scenes, those things, they really don't. When you're trying to do something on two different types of data, like with the same method, it usually won't work. You'll have to have unique methods for the unique data types. And so a good example of that is when you look at a string representation number 1, which looks like a 1 to us. We can see a 1. And then we have like the number 1. And those two look the same without the quotes. Other than that, they're represented on the screen the exact same way, but the computer saves them completely differently. So behind the scenes in memory, it's totally different. Yep, and Vincent asked, are Python lists similar to JavaScript arrays? They are. It's those two terms go hand in hand. So lists are arrays, and we'll talk about those in lesson 4 ordered data structures. So when you have a string and a number together, you cannot just do like an addition problem. You can't put a plus sign between them and just run it. It'll give you an error. And I have that example right here in this code block. So if I hit play, it's going to say, oh, it's a type error. And it says unsupported operand types for integer and string. So it's like, hey, I can't put these two together because I don't know how to add the number one to a string, which is really just a collection of objects. I don't know how to add these two together because they're not the same thing. So you have to do something to convert the data types, make them the same. But then you also end up with a different behavior. And I can kind of show you what that looks like here in a second. But to get around that problem, we can cast. So the next section here, we have casting. When we're casting, we're really using built-in methods that will behind the scenes convert whatever we're putting as an input into and it gives us an output. So in this example here, we can cast our data from one type to another by just simply wrapping the string here. In this case, we have a string which is denoted by these quotes. We're wrapping it and we're saying, hey, we're going to cast it to an integer. So that's what this method is doing. It's an actual method call, and the parameter is the string we want to convert, and then the output's going to be an integer. So if I ran this, now I actually get a result because it's casting it before it runs this operation. And so now I'll say, okay, 1 + 3 is 4. I can do that. Okay. We can also cast things to floats. So that's a different data type. And you can notice the difference between an integer and a float is that decimal point. And then we can also cast numbers into a string. And then if I run this, this addition operation here, it becomes 1, 3. So it's a string with 1 then 3. And that's what that addition symbol does for strings. It just concatenates them. So there's different ways that it behaves depending on what type of data it is. And I can show you another example here. Let me go ahead and add another code block. I mentioned the type method before. So I'm going to do my variable equals. Let's say my name, right? Okay. And then I can run the type. I can run that, and it gives me back exactly what it is. It says this is a string because it is a string. We can see it's a string. This is a pretty useful method to use when checking data types, which we'll need to do that sometimes because you don't know what type of data you're getting in. Maybe it's coming from another part of a script or coming from an API call from the internet, and you don't know exactly what type of data this is. You can run the type method to see what it is. So we can change my variable to 34, and now it's an integer. We can change it to 34.45 and see now that it's a float. Alexis asks, how can we use Boolean types? Boolean types are super, super important in Python. And I have an entire lesson tomorrow on Boolean types. So Booleans are used for conditional statements. And so we're gonna talk in depth on those tomorrow. But we're gonna talk a little bit about them today. There is one limitation though when we're doing casting, and that is, you'll need to make sure the data type is going to fit the format of the caster result. In the example that we have here, we have a string representation of a float because it has a decimal point. But if we try and cast that into an integer, we're going to get an error because it doesn't know what to do with the 0.56 because we want to give us an integer, but we're trying to cast it literally. Well, it can't do that. So it's basically stuck in a catch-22. It's like, I don't know what to do. I'm gonna just give you value here. I can't do this. And So we can't, there's no way around that. Now, we can round this before we cast it. So if you want to, you can cast it to a float and then round it to an integer. You can do that, but you can't just cast this directly into an integer using a casting method like this. It'll give you an error, and it's one I've run into several times when I'm developing. And I'm just thinking, oh yeah, I'll just need to cast this to to this other data type and move on. And then I run the script. I'm like, why is it failing? I look, I'm like, oh, okay, I see why. I forgot to round it, or I forgot to do something with it. So
Sir, can you give us an example on why you would round your decimal?
well, I mean, if you need to cast it to an integer, why you'd want to round.
Yes, sir.
Sometimes
Like why would you want it over why would you want an integer over a float? Because obviously the decimal is more precise, but I'm just curious.
sometimes there's limitations on, like maybe like your customer doesn't want any floats. Maybe they're okay with rounding. A good example of that actually is doing your taxes. When you're doing your taxes, they don't care about cents. They always want it rounded to the whole dollar. I just ran into that the other day when I did my taxes.
Okay,
So,
awesome.
yeah, because I was actually
Gotcha.
going to use TurboTax, and then because
Oh, let me stop you right there, Chief.
I know,
I'm-
uh, I'm a contractor, and so like they're like, oh yeah, to give you the tax breaks, you have to pay for like the super ultra like high priced package. I'm like, nope. And so I moved on to another tax. I went with like Free Tax USA or something. It was like super cheap. Yep, that's what I used. And because TurboTax actually lets you put in the decimals, and I think just rounds behind the scenes, because your W-2s it has the cents. But when I put my information in, or I had it fed into when I read my W-2s, it had already automatically rounded them. So yeah, another
Okay,
example is
awesome.
counting objects, people. If you're getting like an average, right, you'll get like 4.56 people, and you're like, well, I can't have a 0.5, I can't have 0.56 of a person, so you'll round it. So there's times you want to round, or you want to get the floor, so you want to get rid of anything and just go down lower. There's a mathematical operator called floor division that we'll talk about. So yeah, there's many cases. It just depends on what you're doing really. So with Booleans are the most basic data type in Python, right? It's really, when you think about any kind of program that runs, what's going on behind the scenes is, and what you're writing is you're breaking things down to yes or no questions, on or off, 1 or 0. So you can define a Boolean easily. You can say this variable equals true, but you're not typically going to be doing that. You're going to be evaluating conditions that result in a true or false, and then your program is going to take action, go take a path down the logic tree that you've constructed. So it's an easy concept to think about, like, yeah, cool, 1 or 0, easy, right? But it still takes practice to kind of think about how you're going to use them in a program when you're writing it. So and like I just said, Booleans are typically used in comparison operators. And my example here is pretty good, where the result of the Boolean expression is then the logic tree is going to follow a certain thing, and it goes hand in hand with if-else statements. So if you've seen a bit of Python, you've kind of reviewed, you've taken time to review the course now, you've probably looked at an if-else statement. They go hand in hand. You're going to have a Boolean statement after an if statement. So it'll come naturally once you get a bit of exposure to it. So in my example here, this is a theoretical program, like the kind of the meat potatoes of a thermostat, right? So we have our current temperature. Let's say this current temperature really is kind of what's being measured at the thermostat. So there's a thermometer that's exposed to outside air, and it says, okay, the current temperature is 67. And it's evaluating it every second. So it just gets a measurement every second. And then once the temperature drops below 68, so it says if current temperature, is below 68, turn the heater on. So that happens. And so it's still going to continue to measure the temperature. And once this temperature goes back to 68, it'll run this logic and then turn off the heater. And then while, you'll have some sort of other process here at, running this measuring of the current temperature, but this could literally be the logic for a thermostat. And that's exactly what it does. It just measures, gives a threshold, and then once that it looks at what it's evaluating, and then triggers the heater on or off. Like this could be a function to actually turn on the heater, turn on the gas and everything else in your house, or turn on the electric coils. So, yeah, this is just a super basic way to use Booleans, but something like this is it's just going to be a little more complex. You usually have a lot more Boolean statements in true software development programs, but this is an example of one that you could use. Any questions on Booleans? Okay. Move on to numbers. So the two types of numbers we see are integers and floating points. And I kind of mentioned these a bit before, but the mere presence of a decimal point means it's a floating point number. So that decimal point tells you it's a float. Python is smart enough to represent the same values equal. So if I were to do a Boolean statement, and I can do one here. If I could say 5.0 equals 5. If I run that, it's going to come back to true. Python knows that that does equal, but if you change anything, it's going to evaluate to false on any one of these. So, oops, need to make that bigger. And there it goes. Again, I've already kind of run this, but we have type, integer, you run the type function here, and you have a float. And then you can also perform mathematical operations between integers and floats. But your result will be the most restricted data type, which is going to be a float, the more precise data type, if you will. For the mathematical operators, Python. This is a good list of the basic, mathematical operators. You're probably familiar with, most of these. Some of you probably will not be familiar with these two, the floor division and modulus. But we have our addition, subtraction, multiplication, division, and we have exponent, which is just a double star. And then we have floor division and modulus. And I was going to show some examples of these, but they're pretty simple. Also, Python performs these arithmetic operations according to the rule of operations. So the PEMDAS. So we have parentheses, exponents, multiplication, division, addition, and subtraction. One caveat to that is any kind of equal, like either multiplication, division, addition, subtraction, it'll operate left to right. So if you have two equal priority operations, it'll just go left to right with those. So here's some examples we can try out. You kind of do some math in your head to see what it is. But if you look here, if you just kind of think about how it's going to operate, of course, we're going to see the 1 plus 70 first, and then it's going to go run over to the exponent and give us 8 to the 5th power, and then run this division operation, and then finally the addition, which will give us this crazy float here. Now, the two operations that we have that you probably aren't as familiar with is we have floor division and we have modulus. If you take a look here, we have 20 with a floor division of 4. If we run that, we get a 5. Conveniently, that looks just like this one, 20 divided by 4. Okay, but if you notice, something weird happens, right? So we have a float here. This is 2 integers and division, and we end up with a float. But here we have the floor division, and we end up with an integer. Okay, but the thing about floor division is that it gives you an integer. It's designed to give you an integer because it gives you how many times the number on the right can go into the number on the left, and it ignores the remainder. So if I did a 21, I'd still get a 5. Because 4 can go into 21 5 times. 4 can go into 23 5 times. But if we want a pure division operation, we actually want to get the float. We want to get that precision. So now it'd be 5.25 for 4 to go into 21. And so that's the difference between floor division and regular division. Now, lastly, we have this modulus. Now, the modulus, let's go back to just using 20. We use modulus. 20 modulo 4 is going to equal 0. 21 modulo 4 is going to equal 1. And what that is, it's giving you whatever the remainder is. If you look up here in this little chart, modulus returns only the remainder of a division. And so it's going to ignore how many times it goes into it. You just want to get the remainder. And this is a very, very useful operation when you're trying to find like even or odd numbers. And this is the example. So 20 modulo 2 is always going to equal 0. Basically, any even number will be 0. Any odd number will be 1. And so that's a good way to find odd or even numbers. And if you've done some challenges, some coding challenges, you start looking at them, you've probably seen the application of this because you'll find a challenge that asks you to find a odd or even number. So any questions on the numbers, floats or integers?
Not at this time.
Okay. All right, well, let's move on to strings. So here we can open up this link. And what this will pull up in the Python docs is some common string operations that we have. You can also go into like what strings are on the side here, or you can even search it on this page. But this kind of gives you some string operations, which is pretty nice to have. That's one thing about software engineering. I think I talked about this the first lesson. There's lots of good documentation out there, especially when it comes to like the programming languages themselves. Sometimes you can get to some weird libraries if you're trying to use, some third-party library. Sometimes they don't have good documentation. In fact, I ran into one today on my primary job. I was trying to what was I trying to do? I was trying to get this tooltip to show up on we're trying to evaluate like these 2 data sets, putting together on this visualization piece. And I'm trying to get these tooltips to pop up based on what database each point's coming from. And I can get one to show up, but the other doesn't show up. And the documentation for this library is just horrendous. Like it just says, yeah, just type in this help function, you'll see it. And then I do, and it's like, it just gives me an error. And I'm like, I don't know what this is. And I finally looked it up. I found a Stack Overflow message on it. And someone was like, yeah, it tells me go here, but it's not giving me anything. And they're like, yeah, their documentation's horrendous. Like, here's what you can do. Unfortunately for me, I still haven't solved the problem. But that's, good thing about just, especially learning early on is most of the tools you're using when you're learning has very, very good documentation. So you can look at the Python site or you can look at many other like teaching websites like W3 Schools or gosh, I can't think of any others right now. but there's plenty out there when you Google them. But let's move on to strings. So strings, they're also called string literals. They are sequences of 0 or more characters, and they are enclosed with quotes. And there's all different types of quotes. It could be single, double, or triple, depending on the use case. And I think I have some examples down below on those, but really like the single and double, just really, if you have any kind of like quotation mark in your string, you need to use the opposite so you can wrap it effectively. And the triple quotes really allow you to just use multiple lines. But because these are sequences, and they are sequences just like Python lists, which we're going to talk about in lesson 4, we can access any portion of the string that we need to do things. So you saw the exercise we had on day 1, where it was that long string of text. We're trying to find, what's the longest sentence. Well, that string was really just a big collection of characters, and we just needed to go through and find certain characters and then do something with those and use those string methods that we're going to learn about a little further down to manipulate it and extract information. We were able to get the longest word count of a sentence. So but with that, we can access any part with indexing, and this graphic is pretty good. When it comes to thinking about indexing, we have our string Python here. This is a collection of letters. It'll look like just like this on your screen, but you can think of it like this. When we're trying to go forward, every most software engineering languages, not all of them, but most of them start with 0. When you start counting, you're 0 indexed. So you want to start with 0 and start counting up. Python's nice. JavaScript doesn't have this, but Python does. Python has negative indexing, so you can actually just do a -1 and go to the end of your string, and then you start counting backwards. So your string at the index of 1 and your string at the index of -5 would end up with the same result with this word Python. So in this example here, we have my string, this is my basic string. We're going to be accessing individual indexes and printing them out. So if I run this, I'm hitting 0, that's the capital T. And then the next time it runs, I'm hitting my string at the index of 1, that's the H. My string at the index of 2 is the I, and then the S, and then this last one's a space. The space is a character. So this is actual character, it counts. There's a way to kind of see what it is by looking at ASCII tables. And I can pull those up here in a bit, but you have to count the spaces when you're thinking about a string. Spaces have unique properties. They can be, it's considered white space, so you can split your string on white space. It'll do it by default. But that's how you access the indexes. Okay. And so if I wanted to access this, with negative indexing, I would have to count back from the end of the string and just -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I wanted to print that same S, right, I can do print my string at the index of -20. I think that's it. Yeah, there it is. There's the S. So that's the same thing as saying at the index of 3, it's also -20. That's the same exact S. So typically you're not going to combine the triple quote with another kind of string designation. The triple quote really is a catch-all because it's for multi-line strings, but you will intermix, for example, in this string here, you can also wrap this with single quotes, right? So it behaves the exact same way, a string, right? But the problem now, I can't put like a traditional contraction in here. So if I wanted to say like with the regular, double quote, going to the park. Okay, with double strings, that's great. But if I use this with single, I get wonkiness going on because this single quote is also closing the string, and then this Python's going to give me an error and be like, what are you doing? So if I ran this, it's going to tell me there's invalid syntax because it doesn't know what this is because it's not surrounded by any kind of quotes. So, yep, you're welcome. So yeah, so that's a good example of how you would interchange those. All right. A definition of a string is that it's immutable. And this term comes up a lot, but immutable means that once a string is created, I cannot change any aspect of the string. So like when I defined my string, which I did already, if I go down here, I make a new code cell, I call my string and then run it. It still has it in memory and it accesses it. I can see my string, right? But I can't change this in place. And it doesn't really, when you see it with lists, you're going to understand a little more. But basically, I can't access like an index and then reassign a letter to something else. So let's say, for example, I made a misspelling or I had too many letters. So let's just say I put string. Okay, I meant to say string, but I said string. Okay, and I want to change it to this is my basic string. So now I have it string. I want to change that. Well, I mean, I could try and go and say, well, I don't want the K to equal K. I want the K to equal G. Or in this example here, I have this is my string, and then I have a period. I want to change it to an exclamation point. That's actually a better example here. If I try to, it's going to tell me the string object does not support item assignment. So with strings, you can't just change them in place, but you can completely redefine them. And so that's kind of how you get around that. So just completely redefine it or create a completely new string with your changes. That is completely allowed. I can totally change this its entirety to some other string and it'll be fine, but I just can't access a certain index and just change a character. With Python lists, you can do that. So those are, it's okay to do that with those. So in this example here, redefining a string, if I run this here, this is my string, I printed it out, and then I redefined it to my change string, and then printed my string again. Or I just put it in the output, and it says this is my change string. Any questions on immutability or anything with strings so far?
So I do have a question.
Yeah.
You counted 15 letters. Will we be learning a function later that will allow us to count the characters of a string to be able to utilize them in a different fashion, the same way you counted the numbers of the 15 characters and then was able to use that?
So you're saying like how many, do you want to know how many characters in the string? That's what you're asking?
Yeah, so you see how you use the word Python, it's like -5, as opposed to having to take a word and put it in an actual Excel frame and say, hey, 1, 2, 3, 4, 5, or counting however it is. Is there a function that's out there that would count those characters for you?
I mean, you could count everything with a loop if you want to, but if you want to like know the length of a string, for example, so we can go back down here and look at my string, right? I can just say length of my string. That will tell me how many characters there are. And so now I at least know the length of it. If I want to like see which one is like what index, you can use a loop, which we'll learn about in lesson 6, but I can show you here. So here we can say for I letter in my string. Oop, little typo here. Oh, not, we need to enumerate. Enumerate. There we go. Print I letter. We can do that. And so now you know what index, what letter is at what index, if you wanted to. Typically, you're gonna
No, absolutely.
yeah, you're gonna have other ways of doing this, but this is one way to just quickly see a small string. Right. Sorry, I put this back the way it was. And hit play. There we go. Any other questions on strings so far? Okay. We can move on to slicing strings. So just like we saw with indexing, we are also going to use bracket notation to slice a string. This is where we can just take portions of a string and see it. So the difference, of course, is the presence of 1 or 2 colons, which will tell us kind of where to start a slice and kind of the step. But if you take a look here, the syntax is you have your string and then you open your bracket and you can have these 3 things. You don't have to have your start and your step, but you must provide something. You must provide Python a place to stop. So if you omit the start and the step, they default to a certain value. So the start will default to the beginning of the string, and then the step will default to doing every letter. And so if we take a look at the change string now, right? If I go ahead and run this, what I'm saying is I want to slice the string and return back just a portion of it. I'm not changing the string at all. Python's not redefining it. It's just returning a portion of the string. Now you could redefine this as a new variable if you wanted to, so you can pull out the word changed. But here we're saying, starting at index 11, I want to start extracting, out of this, this is index 11 right here. And then I want to stop at index 17. So the thing about the stop is that it is up to, but not including when we go to our stop. So in this case, we're specifying the start and then the stop. And if we want to specify the step, we can do that. We can do every other letter. And now it just gets rid of, it just goes through every other letter versus getting all of them. We can also just make it a 1 and then get back the same result, but it defaults, so you don't have to include it. If you omit the start, it'll just come from the beginning all the way up to, but not including index 18. So that's where that will stop. But in this case, we have 11. We get the word changed. Below here, just like I showed you with this one, we get all characters from index 0 because I'm just omitting it. And I'm saying I want to stop at index 3. So we put a 4, up to, but not including. This is really important to think about. And it's okay when you're running code, you'll make the mistake and go too far, or you won't go far enough. You realize, why am I cutting all the last letter off every word? You have to go 1 over so you can get that last one. So we run this here. My string starting at 0 up to, but not including index 4, which we knew was a space, is the word this. Conversely, you can slice it and then omit the stop index. So you have a start index, and then if you omit the stop. Here I went from -6, it just moves all the way to the end of the string. So in this case, I'm going to start at, my string here, I'm going to start at -6, so it's -1, 2, 3, 4, 5, 6, and go all the way to the end. So I was extracting the word string, my string, and then I'm going to go ahead and print it here so y'all can see it. There we go. Any questions on slicing? This is a really good thing to practice. There's a lot of times where we need to slice strings, especially when it comes to extracting data. Like you get a big feed of data in, and you're trying to extract certain things, you may have to slice a string. So I would practice that. We can use the string slicing to reverse a string by specifying, nothing for the first two, the start and the stop, and then just use -1 as a step, which means it will go backwards. So if I ran that, that's how you can reverse a string quickly, by using the string slicing. I believe this is how you'll do it. I think this will work. Yeah. So here, what I'm saying is I want to start at -1 up to, but not including index -7, and I want to go backwards one letter at a time. So now it's string backwards. So I just went right from here to here, but the -7 index is a space, but it's up to, but not including, so it only goes to -6. Any questions on that?
Yeah, just what the -1. Yeah, the -1 step. What that mean again? Sorry, I got half twice, but -1. What does do?
So that's the step. So if you remember, go back up here, right here. So when you're slicing a string, right, you have your start, your stop, and your step. The step is, basically, if I were to do -2, I would step over every other letter, so it'll just shorten it. So it would start with like the T, it would skip the H and go to the I, skip the S, give the space, and then we get the S, skip the space, get the M. So basically it's grabbing this one, this one, this one, this one, this one. It's stepping over each one. So that's -2. But I'm doing it backwards. So I'm just using this string slicing to reverse the string.
Can we do it in forward, so I can imagine? I got what you. Yeah, can you give example for the forward, the regular, the normal direction?
So there's the normal way, right? 1 or do 2, right?
Yeah. So we start at 0 index, right?
Starts at 0.
Not including 0.
Yeah, if it's not there, so there's nothing there, it's assumed to be 0. And then if this one's not there, it'll be the end of the string.
Usually we have to put something at the stop, right? We cannot leave it 0.
Well, if you're including the others, it'll assume it. So if you don't put something there, it's going to put it to the end of the string. But what I'm saying is, if you omit the other two, just one number is the stop. So
one number stop.
One number is going to always be the stop. You don't have to have any well, you have to have a colon, but like there, right? So that's going to be the stop index. You have to include that if you have no other numbers.
Right? Okay. And we step like if we put like, yeah, the same one, 7 and then the colon and then like 2 step.
Then you're going to get the T,
Then-
the I, the space, and the S.
Yeah.
Because it's just basically skipping over each other letter.
So okay, so it's like we skipping the second
Yeah, you're-
letter.
yeah, it's stepping over. Yeah, it's so basically that's what the
We step on it. Okay, yeah, I got it. Okay,
cool. Yeah,
thank you.
you're welcome.
Hey, Aaron,
Yeah,
can you just put maybe just 2 colons in there? Does that just copy the entire thing?
yep.
And if you put a 0 for the start. And this had a length of 25, so would you put 25 or 24 in the middle?
You don't have to.
But let's say you could, right? Just to make it obvious?
If you
Is that-
do, if
that's
you
the end?
do, you're gonna omit the last letter.
Okay, you can't put 26 then to make sure you captured the last letter?
No,
And then can you
because
put- how does that look? That's the same thing. And then if you put a -1 at the end, the step, that's what you were showing us earlier, right? That's the entire string reversed.
no.
Why would that not work?
Well, one, I'm starting at 0,
Uh-huh.
and then I'm trying to go to index 26, but I go in a negative direction. It makes no sense.
Mhm.
So it wouldn't work. In fact, I think if you let me try this. You're actually going to things I don't ever do this really. Like so you can go beyond the end of the string. That's what I thought. Okay, so you can go beyond the end of the string and it'll stop at the end anyway, right? You can't do that when you're indexing a string. So if I try to access something that's outside the bounds of the string, so if I try to access index 30, I'll get an index error. But with slicing, you can go beyond that and it will just not count anything else. But if you put the exact number, so if remember, what's the length of it? It was 25, right?
Correct.
So 25. If I put a 24, yeah, it's going to start cutting off. So I think the length of my string is print. It's not the last item in the line. Okay, so it's 25. Yeah, that should be, let's try 0. No, that works. Okay.
But it's the step that doesn't.
Oh, okay. So yeah, there's 24 indexes. So if the G here, that is index 24. Okay. So and I can show that here with that loop I didn't have, but anyway, if I were I can just give you that string right there by doing my string mix of 24. Okay. I'll print that. So that's the G. So we know G, and this is my change string, is at index 24. If I were to put 24, so that's as the last index, it will not include the 24th index.
Right.
So we'll not include the G. So we put a 25, or you can just omit it. But you have to have the 0. If you did that, then you'll get the whole string. That will assume at the end because you put another number in there in a colon. If you put nothing, and you have yeah, if you have a colon like that, and you put, yeah, if you put a colon in there, it's going to assume all the way to the beginning and all the way to the end of the string. That's a full slice. And then that's also a full slice because you're including a start, which then assumes a stop, and the step as well. The step has been omitted. So the act of omitting is actually removing the colon, not the number itself. So right now we've included the start, and the stop, because it's defaulting to the end, we did not include the step. The step isn't included here, but Python assumes it to be 1. That's why it gives us every letter or every character.
So why when we add the step -1, it remove all the characters?
We want to move backwards, you do a -1. So remember, it was -1.
Yeah.
And you're going to do your start and your stop, which is
Yeah.
those default to the beginning and the end. And so it's going to go from the end and go all the way to the beginning.
So what if you put -2? What does that do then? Oh yeah, it's gonna skip every other one, but backwards.
Yep.
Is that correct? Okay, I understand. Awesome. I thought you had to put a negative, like -1, and then go to the -25, and then put your -1 to be able to force it read it backwards. But I understand. It already takes that into account when you put the negative.
Yep.
Awesome.
So in this case, the step will be the first space, like my string, and then the bracket. The first one, that's the step.
The first one is the start index.
Then the start index or the step in the backward.
It will still be the same. Like this is always going to be the start, the stop, and the
When
step.
Okay, so we're gonna step from backward.
Mhm.
Okay, starting from index 0 and stop by 0.
It'll go to the end of the string, whatever the end of the string is. Like Python will interpolate that and put those and calculate those figures for you. But if you specify something, then it'll behave a different way.
Yeah. Okay.
I have sort of a simple question on the slicing the strings. Can you hear me?
Yeah, I can hear you. Go ahead.
Oh, okay. Sorry about that. So when you're pretty much, best way to explain this, kind of, when you're calling on the syntax to slice a string, do you have to type out string bracket start stop step, or can you just type out, like for example, my string, add the colons and the brackets, and that's kind of the indicator that we're going to be slicing the string?
So yeah, when you have the open bracket, like as of right now, I'm going to either grab a single index or I'm going to do a slice. And then if I put a single index, now I know I'm just grabbing one index, and so I'm just going to grab one letter. In this case, it's a space. But if I do any kind of colon in there, then it's going to be a slice, because now Python knows, okay, we have a start and a stop right now, and it's the beginning and the end of the string.
So you wouldn't need to call out the syntax of string start stop step. That's just kind of like the indication of what's going on.
Right. So this is just illustrating what these positions before this first colon is the start, the middle is the stop, and then the last one is the step. But you don't have to put anything in there as long as you have the colon. Now I've given Python two things. I've given the start and the stop, and they are right now the beginning and end of the string. I could say 0 here and still get the entire string. Start at 0 up to, but not including up to the end of the string. If I did a 24 for the index, then it's up to, but not including index 24. So it won't include the G. I could go beyond. I could just, if I didn't know, like, oh, it's 456. I know I'm going to get my whole string at that point. Like, you could do that. But you can just omit it and it will just take you to the end of the string. So the presence of the colon kind of tells you how many figures you've given this bracket notation for a slice.
Got you. I was just kind of in the thought process of that we're kind of calling on it like a function, but if it's just indicated by the colon in the brackets, I understand.
Okay.
Yep. Thank you.
Yep. Cool. Let's go ahead and do this little quick exercise. Assign a new string to a variable, and then print a single character and a slice of that string. While we'll do that, let's go ahead. Let's take about 2 to 3 minutes to do that. And we can then go on break until 7:13 or 7:15, and then we'll resume the lecture.
Where do you want us to do that?
What's that?
But when do you want us to do this exercise?
You can do it now, or if you don't want to, it's fine too. Either way, this is for you. So,
Okay. I
yeah,
thought you want us to do it for and I mean show it. So that's why I'm asking where shall I do it? And
yeah,
share
you
the
can
screen.
do it. And I'll ask someone to share if they've done it in the chat. But yeah, you don't have
Okay. I got it. Yeah. Okay.
It's up
Thank
to
you.
you. I'm not going to go anywhere because I really don't need to go on break. But does anybody has anyone tried to do the code spaces thing and try to get the Jupyter notebook running there, or have any questions on that? And I'm going to pause the recording. Give me a second. All right, welcome back from the break. We've had some entries in our chat. One of the first ones was printing the entire Navy Creed, which, I mean, sure, that's Navy Creed. As they shouted at the football game. But here, we're actually, I changed a little bit and I said, Navy Creed, and I gave it a slice, and then I multiplied it by 3. So I had it kind of combine a string slice 3 times. So I changed it to Army, Army, Army. So that's a way we can kind of print a slice, and then do some operations with your string. If I wanted to just print the word Navy, what would I put in here in my print statement?
Print Navy.
Navy Creed. Yep. And then I want a slice of it. So what would I use for indexes?
3, 7.
From 0, 1, 2. We're gonna start from 2.
2?
Yeah.
3, I think it's 3, 7.
No, 2, 0, 1, 2. Oh, 3. Yeah, start from 3. Sorry. Start from 3. Yeah.
Okay. And
7.
7, right?
Yeah.
There we go.
Perfect.
Because the 7th index is the comma, but we're up to but not including, so it'll go to the Y.
Yeah.
Cool.
Aaron, one of the things I found helpful is if I know I'm going to start with 3, and I know Navy has 4 letters, I just add 4 to 3, and I know where to stop.
Yep. Yep, that will go up to but not including. So that's a good way to do it. Good way to think about it. Okay, we have we'll put another example up here. Let's see. We'll just do another code block. Here we go. Run that. We have bootcamp as code platoon, print bootcamp with the index of 5. The length is 12. Print bootcamp -7, which is the same, capital P. And then the slice is 0.4, which is code. Very good.
Yeah, but how did you declare the variable bootcamp in Python without making the underscore between boot and camp? Oh, it's like one word.
Oh, I mean, you don't have to. I mean, you could still define a variable like this if you want to. So bootcamp like that. Of course, I would need to change all these. But
No, I mean for Python, should be boot camp, like there's underscore between boot and camp, and we have to declare it, or no need to declare in Python. We don't need to declare at all the variable. We can put it as is like that.
Yeah,
Like
without
let.
to declare it. Like in JavaScript with let, const, and bar, you don't need to do that with.
You don't need to declare the variable in the
No, you don't.
yeah, but you don't actually declare. You just write it out. Like this is what I wanted to find, and with this single, this is the assignment operator. So as long as that's following whatever you're putting in, then it'll define it.
Okay.
Yeah.
So how we can avoid the problem of overriding?
Avoid the problem of what? I'm sorry, I didn't catch that.
Overrid.
Overhead?
Overriding, or call it overrid. If we have like 2 variables with the same name,
Mhm.
you know what I mean?
If you put another variable called boot camp and you assign it, it'll just override it.
Yeah.
Yeah, so if I did here, I did another.
Yeah, how to avoid the problem the problem of overriding?
Yeah, or redeclaring if you
Yeah,
want.
I think,
Reassigning.
can I try to ask you this question for you? So in JavaScript, there are some immutable, right? So const, you can't change.
Oh, I see what you're saying. Yeah.
Let,
that was-
you can. So,
Oh, that's what he was asking.
or you also
Oh, you're
can.
good. You're good.
Yeah, so with const, you can't redefine it because that's like a trigger in like JavaScript. It'll say, okay, you cannot redefine this. It's a
Right.
constant, right? But with let and var, you can redefine it, which you can do in JavaScript. But yeah, with Python, you don't have the ability to lock something in as a variable.
So in Python, there is no constant variable. It's all like.
No, so typically constants are going to be all capitals. So if I wanted to make something that tells people that
Yeah, that's what I'm
it's a
asking about.
constant,
Okay.
I could do that, but it still can be changed. Someone can still change if they want to. So
You can change it even if it is constant variable?
yes. Yes, you can. So there's a lot of things like that with Python where like you'll have variables like an underscore in front of it, and that tells other developers that this should not be changed or it should not be converted anything, but there's nothing really limiting people from doing that. So let's move on. We'll go into string methods now. It is important to kind of think about these. You'll be using these in your coding journey quite a bit because there are ways to manipulate strings and to help you use them appropriately. We're going to start with some pretty easy ones here. The first one is string.upper. So this one here will convert all characters of a string to uppercase. And really what this one and the next one, string upper and string lower, do, they allow us to ensure consistent formatting if we're using it to compare as to incoming data. So if I run this here, I have my text and it's all lowercase. I can redefine it, the result of text.upper to a new variable, and then I can print it. And now if you look, hello world becomes all uppercase. The same with string lower. It will convert all the characters in the string to lowercase. So here I have hello world as well as text, but now I have a capital H and a capital W. If I were to run this, it then makes it all lowercase. String capitalize will capitalize the first character and make all others lowercase. From that, it does not capitalize the other P, it just only capitalizes the first character of the entire string. So this is good for capitalizing titles or just making sure that you have a capital for the first character. Title case, of course, does both, or every single word will have a capital letter. Behind the scenes, Python is doing a lot with these. So what's nice, you don't have to think about what it's doing behind the scenes. All you care about is, hey, I have my text and I want to run this method on it and I want to see the result, right? Your input's going to be the text and then your output's going to be whatever it returns and you want to save it to a new variable.
Can you give us like simple problem example to using one of those, like capitalize or title or the uppercase or lowercase method? Like
Sure.
how we gonna face this in the real situation, the real problems? When we Okay, so
Let's say you want to make sure, like, it can be used for like basic, password verification, where it's not so case sensitive, emails, right? So if you think about letters, if we take a look at ASCII characters, letters in programming are actually defined by codes. So, and I believe I have a link to it in the pre-course, but I'll open up a Google. I'll open up in Google ASCII characters here. So ASCII table. Okay, let's see. I'll go to this one, the .edu site. Oh, that's a terrible one. Let's try and find a better one. Okay. This one is also okay. Okay, so taking a look at this, you have these like these values here on the left. You have 65 here, 66, 67. Those correspond to the letters here. You have a capital A, capital B, capital C. On the flip side, you have a lowercase a, which is a 97. And then B is 98 and C is 99. There are string methods in Python which allow you to access those characters for ASCII, and you can make something that's case sensitive, right? So you can make something that evaluates like a password that makes it case sensitive, or you can make it like if you're just trying to accept an email and compare it to something else in the database. So let's say, for example, someone has an email in a database already. They made a user account, they have an email, right? And their email is saved as, let's say, user email equals, and it's going to be Matt .smith@gmail.com, right? That's how they entered it in the form. That's how it's saved in the database, right? But what's the difference really? On an email, if it's a capital or lowercase, there is no difference, right? But if I were just to use Python to compare the two, so let's say they try to log in, right? So login name equals, and let's say they try to enter one, and I can actually put input, and I'll do what is your email? Or enter your email. Let's do enter your email. Enter your email, and I'll put a thing there, right? And we're getting into a future lesson, so I'm not going to go too much into this for now, but if login name equals user email, print access granted. Okay. We could write a simple script like that. We can have an else statement that says try again, or you're not allowed in, right? So if I ran this, it's going to ask for me to put my email up here at the top. See, it says press enter to confirm, right? So if I put matt.smith at gmail.com, okay, that should work because that's the same email. But if I hit enter, it's not going to give me access granted. Now, if I said if login name dot lower or dot upper equals user email dot upper, and I run this again, and now I do all lowercase, matt.smith at gmail.com, and I hit enter, access granted.
Oh, I got it. Okay, that's a good one. Thank you.
You're welcome.
Could you also do that if you just put lower instead of upper?
Yep. Yeah. So
Okay.
both of these are acceptable for ensuring constant formatting.
Okay,
will-
awesome.
You're really forcing it to go to a certain state. And behind the scenes, what Python is doing is it's saying, okay, what's the lower, if I'm going to lower, it's gonna go look and just use a simple subtraction operation or an addition operation to convert one character to another in the ASCII table. That's what it's doing behind the scenes. You just don't see that methodology. You don't see that because it's all included in Python code.
Gotcha.
So all you have to worry about is thinking about, okay, dot lower, boom, I'm done. So. I've never used capitalize or title and on the job. So, this is just an available, method to you to use. Some other people I'm sure have used it, but some of these methods I'm going to show you, some are more common than others. So we'll need to think about that too. But yeah, so just note that this one capitalizes the first character of a string, makes all others lowercase. If you notice, it makes them all lowercase. So I think if I have like if I have a capital in here, right, and I run this, it's going to force the others to be lowercase, but make this one capital.
We can use it, like for example, and when we create a password, okay, and in some website they ask some of the word should be capital word, right? Or the first word, something like that, right? So we can use it. Yeah, we can face this. We can use this method.
Yeah, and you can use these methods too, like if you're doing some like web scraping or something, you're trying to get some information, and there's errors, there's miscapitalizations, or you're trying to refine some text. You can use these methods to change strings to reformat them. That's a very big possibility for these methods. So
yeah.
Moving on to the strip method. So we have string strip, and this one removes the leading and trailing white space from a string, and that's useful for cleaning user input. Or using, like, if you scraping something from the web and you have extra spaces, you can quickly clean out those extra spaces by doing text.strip, and then it just gets rid of everything on the outside of the string. So here I have a bunch of spaces here. You can see those spaces, and I printed it so you can see that it actually, those spaces are there. When I run text.strip, and then call and show you strip text, it got rid of all those spaces, just had a nice clean string. So this one's pretty good for cleaning user input or with data. I have used this before when using like character recognition software and getting results of that. And then we had to clean the data. We used strip. We started with strip, and we used some other methodologies to fix words. To make sure they all were correct when we got the end result. So you can use that with Python. We were doing some image, like we were reading like old maps, and we were cleaning up the data from those maps. We did use strip to evaluate strings that the software had picked up on. Starts with and ends with. You're going to want to input a parameter in those, but basically allows you to check if a string starts with a specified prefix. So in this case here, we have our hello world text, and we want to see if the text starts with hello. So if we run that, we get a Boolean back. This can be pretty important when doing like a check to see if let's say you're requiring someone to enter their personal website, right? Well, and it has to be a valid website, then that they're going to have to start with like HTTP, right? And if they don't, then it's not a valid website, and you can offer some logic gates there and say that's not a valid website or something. So you can use that for like logic checking. You know, if their website address does not start with HTTP, then you can say, oh, you don't have a valid entry there. So that could be a good use case for the starts with. Same with you can check the end of a string as well. In this case, like same with like website example, you could use it to, you know, let's say they're forced to put in a .com website. So you can say if their entry, you know, ends with .com, then it's good to go. But otherwise, if it's not, if it ends up in false, then you can provide other logic to tell them to fix their website or provide a valid one. So it could be used for, you know, validating entries, you know, filtering or categorizing strings. You can use it to see if something just exists in a string without having to go into further logic. So, you know, because that will just give you a Boolean. Conversely, you can use the find method to actually find the index of a substring. So you could say, like, let's say you have you're doing some web scraping and you're looking for, you know, let's say you're looking for, I'm trying to think of just a good example of something. Let's say you are looking for
like if I'm looking for specific character
or word, really just a word. So let's say you want to find, you know, you're going through an article and you want to find all the mentions of like a country or something else, right? You can put the country name, and if it's not even mentioned in the entire thing, you'll get back a -1. But if you find it, then you'll get back an index of where it is. So in this case here, in our text, we have Python is a powerful language, Python is fun, text find Python. Of course, the result's going to be 0 index because it starts with the word Python, but let's change that to powerful. And put back our quote because we accidentally deleted it. There we go. And now powerful starts the index of 12. And so now I know this substring is somewhere in this string.
Is that also going to give you how many words? So the word powerful, is it also going to tell how many powerful words, if that makes sense? Like
No,
how
so
many,
it's only going to be the first exact match.
okay.
So if I want to find the word is, right? If there could be other words that contain is, in this case, there is not. But if I run this, the word is found at index 7, but that's not the only one. There's another one over here. It just didn't tell me that one.
Okay.
So,
Awesome.
So you'll have to find another way to get any additional ones if you need to. But this is a pretty powerful one to like if you're scraping web data and you want to find websites, you can look for like www. And then then try and, you know, you can find the end of the string by adding an arbitrary amount and finding like the .com in that substring, and then you can narrow it down and find your first and last index that way.
I have suggestion, I have answer for this question. To count the number of words, to find it and count it, how many one do we have? I think we can use the iteration method, right? Like we can use for loop to find the number or to count the number of words inside the string, right?
Yeah, or you can use the count method, which is right here.
Oh, okay. Oh, so there is another method easier. Yeah. Okay, that's right.
Yep. Yeah, you can use a loop. So you could totally use a loop. But you'll have to, like, you would have to like know when you've gotten through one. So it's, you know, using a loop. Like if you're looking for the word is and you want to just use a loop to do it, you could say if the letter I'm on is I and if the next letter is S, count that as a good to go and then move on. You could do that. There's the ways you can do it with a loop. This just makes things a lot easier.
Like we can make function, and we can create the what we call it, initiative variable, or we assign like 0 for this variable, and then we start the loop for loop to count right inside this loop the number of You know what I mean? You know what you got me, right?
I mean, I know of ways I could do it with a loop. I mean, I would just loop over every single character and start with, you know, if I would enumerate and find the index of the first, like if I reach an I, then I'm gonna look for the next character to see if it's an S. If that's the case, and I found the word is, then I'm going to record that as a count. And then I will just keep looping through until I find the next one.
Yeah.
So you could do that. You could totally write your own function to do it. This one also will help you find the first one at least. And then allow you to do other logic to find other ones. You can always run the count method to find how many times a substring is inside of a string. So here, in this case, we have, you know, we're looking for a count of Python, and we found Python twice. How many times is this one going to be found?
Yeah.
Right.
Python twice.
With a capital P, it is. But with a lowercase, now it's different, and so it won't find it. So there's a limitation to that. You'll need to do use your other methods in conjunction if case is not a priority for you. So if case sensitivity is not priority to you, then you want to figure out another way, like maybe make text dot lower dot count.
Yeah, exactly. And we can make this Python. Yeah.
Yeah, that will work. So you can just make your entire text lowercase and you'll find Python. You don't have to worry about case at that point.
Yeah.
So you can string these string, you can group these string methods in the same line if you want to, and you don't have to. You can always define, you know, a new variable called, and I would actually recommend you do this way, right? So if I want to search for Python, but I don't want to worry about upper or lowercase, like letters mixed in, you can just go ahead and say, and then you can say like that, and you can find it.
Dot count Python. Yeah.
Aaron, you say that you would recommend us doing it this way. Is it because it's more readable or it's better practice for us learning?
Just better practice for you learning. I mean, eventually you'll learn how to string them if you kind of know what's going on, but it's, you know, you're not gonna tax your computer by defining new variables and then just seeing every step. It's
Would
just
you, if someone were to put on, let's say, a new line 3 and it just said target equals Python, and then instead of using target is Python, and then to put in target the variable in as an argument, is that taking it to an extreme, or is that something you recommend just to like really get our thinking clear?
I mean, this will kind of show you how you can, you know, turn everything into a variable. That's really good. In fact, you know, in this case, if you have a method that's giving you different things to look for, you know, this could be a way to do it. This actually kind of abstracts things out, or, you know, it allows for more flexibility when you do it this way. So while this was originally written like this just to show like how it works, but you're taking a step further by showing me, hey, can I make this a variable, and then, you know, can I do it this way? Yeah, you sure can, because target now does equal Python in memory. That's exactly what it does. It still came with a result of 2. So
you would kind of recommend this code, or is it extra? Like,
I don't think it's extra. I think it's fine. It'll help you keep track of like how you're defining things. Now you can get to a point where like you'll have like sometimes too many in your code. You're like, I don't remember which one's which again, and you have to kind of go look back up. But that's not a bad problem to have, especially when you're beginning and you're feeling your way around, like defining variables and reusing them. And you'll find that you'll define variables and then you didn't even use it. And you're like, oh, I didn't even use this variable. And then you can delete it. I did that when I was learning. I didn't know, I made lots of variables in the beginning, especially when I was using loops to iterate over things and then, do some counting or changing something. I would define empty variables or like an empty variable as an empty string and then put something in there to hold it, use it as like a flag. There's other ways to do that, but when you're starting out, that's perfectly fine. It helps you see how code works. And so that's completely acceptable. And you wouldn't get dinged for doing this. The beauty of development is that there are many ways to get this stuff done. As long as you come up with the end result, especially in the beginning like this, you're not going to impact the CPU, you're not going to impact memory really. Later on, when you start working on the job and you're now like, trying to save, resources, let's say cloud computing resources, and if your script is kind of being a bit extra and it's actually causing, more compute time, then you need to start thinking about resource saving and everything else. With this stuff, you don't have to worry about it.
Thank you.
You're welcome. All right, moving on to the replace method. So this one here replaces all occurrences of a specified substring with another string. So this is good to do quick transformations. In our example, we have a date formatted with slashes. We want to quickly make it into dashes. So if I ran this, now I have I'm printing my date string, kind of show you what it was and then what it turns into. So that's a quick way. So you just want to start in this replace. It always takes two. It takes two parameters. So if I omit one, for example, and try and run this code, it's going to say it expected at least two arguments, but got one. So it's like, oh yeah, I need to actually put what I want to turn it into. So here, I want to replace it with a caret symbol. Instead, I can do that. And then I can change it that way.
No, that's good.
All right, and then we have split and join. So these two are used quite often, and so these are really good to practice if you can. And gosh darn it, I have a typo on my thing. Okay, there we go. And so the split method will split a string into a list of substrings. So I've talked about lists, and you've seen a couple examples of lists that, in the first lesson. But what the split method will do is whatever delimiter you put in here, it'll then just divide the data on that delimiter. It won't save the delimiter though. So if you specify the slash, you're going to get a list that looks like that. And you won't see the slashes anymore, and you won't have them anymore. But what this is nice because now you can kind of break up your data and do something with it. You can also then iterate over this list, and you won't be iterating over characters in a string anymore. You'll be iterating over items. So if I were to loop over this string, right? Python will look at each character, boom, 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 each one, right? But if I split the string into these chunks, right? So now I have it split into 3 distinct items. If I were to loop over this list, I would look at this as a whole, 3/14/2024. Then I could say, hey, is the last item in my date string split 2024? If it is, then do something. If it isn't, say this is too old or whatever. Like, you can always do all sorts of stuff. You could also just look at the last characters in a string if you want. You don't have to split it, but this could be a case to do that. So you will split things a lot to look at, to extract data out, to manipulate it. And we're going to get into data manipulation when we get into loops, where we're taking data and we're like extracting something out and putting it into a different form, because really that's that's also the meat and potatoes, a little more than, you know, it's a little more advanced than just foundational stuff, but data manipulation is a very important concept to learn very early on. So you're not going to be underwater when you see them doing it in Code Platoon if you get in, because it's going to start pretty quick with the data manipulation. And some of your exercises involve you changing data types already. So in the application challenges, so you have to learn it anyway, but this is one of those ways to do it. You're converting a string into a list, but you're kind of splitting it up. So and so I have my split date now, right? So I made this split date variable. I split the string into split date. With join, we can join it into a single string using the current string as a separator. So it looks a little weird the way you write it. You want to, when you're joining something, you're going to start with what you're joining it on. And then you're going to say dot join and then put whatever, you know, collection you are, that collection is going to be your parameter. So if I run this here, now I have 3/14/2024. I basically did the same thing with replace, but I did it with 2 steps and split then join.
Okay, I can understand why we split the string, okay, to work on it. Like if we wanna compare something with another thing in another array, but why we gonna use why we gonna join it? That will make the manipulation or dealing with this list, right?
Yeah, I mean, you'll join things sometimes whenever you like, let's say you're doing some data cleaning and you have to separate, like, you know, lists of web addresses, and, you know, let's say you're having to, you know, add
You know
in.
what I mean? When we break something, that make it easy to play, to work on it. But merge joining, why we're gonna join something?
Like if it's your final result, let's say you want to, you know, get a string back as a final result after you change something with split, you can do that. You can just put it back together with, you know, with join.
Like, can you give us example, like problem?
Off the top of my head.
Aaron, I'm wondering if we created an array, I'm sorry, a list. If we create a list and we can use that with one variable, and let's say it's called grocery items, that we need to make a list of grocery items. But once we have that list, now maybe we want to text it to someone or whatever, and we use join to convert the list to a string, and then we just send the string.
Yeah, you can join it on a new line too. So let's say, for example, do like that. Let's see. Hold on. Is it maybe backwards here? There it is. I've never joined anything on a new line, so I could be off base here.
But could you create a list of grocery items and then use join to convert it to a string?
You could, yeah. I mean, you could totally do that, and then you have a string to work with. So if I have let me just make a new block here. So bread and milk and cookies. And then I can say, could do like that. I mean, it will show up like that. That could be a way. I mean, I know it's like a craziness. I could also have just a space.
Or a comma?
Yeah, or a comma. Yep. So you can do it like that, or comma.
And then you could text that to someone or whatever.
There we go.
Okay.
I
Yep.
have a question, sorry, just a second, on the join.
Mhm.
So, both ways can work, right? So you could do grocery list dot join and then parentheses, whatever you're gonna join there,
Mhm.
and the other way around, right? So right now, you put in whatever you wanna join in front of the dot join.
Correct.
But on top, when you have the str dot join parentheses, I think about it as whatever comes after, if that makes sense, instead of what comes before.
You're talking about how this looks kind of weird and out of order.
That looks kind of weird, yeah, because
Yeah,
Yeah,
that's, I prefaced that in the beginning because, yeah, it took me a while to wrap my head around, like, why is it split this way? Like, why is it presented this way? But it's just because you,
Use this to join this.
yeah,
string.
you're using this to join that. Yeah, it's just the syntax of it.
but us, yes, yeah, okay, I think I got it, but I'm also thinking, can I do it backwards? Can I say grocery list dot join, and then in the parentheses, put a comma inside? Would that produce the same result?
No,
Oh,
That sounds more like a JavaScript syntax.
right, okay, I see, okay, thank you.
yep. All right, let me. Okay.
Mhm.
And let's see here. Yeah, so that will work. Split again. Split. Let's do it this way. There we go. Looks like we have another space added there, so that's a little side effect of the splitting in of the space we added, so we can always get rid of that space. I think then it will. The reason I put a space after the comma was so it presented nicely on the joined list back into a string. But then you have to consider the extra space in the end result. Now we have like extra space in this milk and cookies.
And if there is nothing between the backticks, like the comma, if there is no comma, just like the one in the first example, it's gonna be by default the backslash.
What's that?
Like how you did now. Okay, you cancel the comma, right? And you
Uh-huh.
just make backticks dot join grocery list. So why it look different than the first one? The date, merge date.
So, well, this one I'm saying just mash them together. There's nothing that's going to separate them. So this is just empty string. You could do that and just put everything into one, like to one string with nothing separating it. But when you add the separator, it just kind of gives you a nice visual separation.
Why did you use split again instead of just split?
You talking here?
Yes.
So you're asking me why I just put this in here, this, and why I wrote it out here, or what were you asking?
Why does it say split again instead of just split?
Well, that's actually, there's a really good reason why I did that. So if I did this right here, okay, and I ran this, that will run fine, okay? But now later on, and I can run it down here, If I try to run split now, I've redefined that method to equal the split version of join grocery list. I can't use it anymore. So let's say I have a new list now, or I can just redefine this one again. So bear with me while I move this over. No, I want I just want a string. Sorry. I want a string equals. Let's do an underscore. Let's actually hit shift when we type that. There we go. Okay. Goodness gracious. Maybe I didn't define it, redefine it. Let's see. Split on white space. I think I just leave it like that. Oh, print. Oh, it still worked. Okay. You got to be careful when you define variables that that are also Python methods. I think this one, because of the dot method, it's not that big of an issue. But if you did the word like sum, for example, sum is a list method, which we'll talk about those list methods, where you can put sum of the sum of my list. If it's list numbers, it'll just add numbers for you and get a sum. If you define the word sum like as something else, you won't be able to use it until you restart your kernel. In this case here, I think it's not actually redefining it because this is a dot method, so it's never going to be at the beginning. But there are methods where you'll want it, like length, for example, len. So when I do a length of a list and get a count, then you can redefine that, and then you won't be able to use it until you restart your kernel because you defined it in this session of Python, if you will. So you just got to be careful with that. In this case, it did not redefine it, so I could use the word split. I just said split again, even though I had only split it once, so I could have called it split. You can call a variable anything you want. I could have called this chicken, and Python won't care that it's actually the word chicken. It'll just know chicken equals join grocery list dot split. So you can define variable names with anything you want. You just want to be descriptive for other people reading your code. So was that kind of the question you were asking, I guess?
Yes.
Okay, yeah, I was just totally avoiding using the word split because it's the name of a method, so I just use split again.
Right. You want to try not to have variables be the same thing as methods.
Correct. Yeah, that's why I use a lot like my string, my list. List is the one that gets overwritten a lot. Some people will say list equals this. Now it's like, oh, now you just got rid of the list method, which is
Hey, Aaron.
Yeah.
If for whatever reason someone just liked the word split, but they recognize it's kind of a key word, could you put an underscore in front of the word split and just use that? Or is there a special significance to the underscore needing the name of the variable?
Yeah, so an underscore in front, in like if you're coming from if you know Java, Java has a concept of a private variable or a private class. And they have in Python, this is kind of like universal language, like, hey, this is something that is private and it should not be really changed. It shouldn't, other parts of code should not change anything that deals with this variable.
Okay.
But again, the actual safeguards are not really there for Python, so it can totally be edited. So
does the same apply to a $sign? Is there significance to a $sign leading the name of a variable?
In Python, No, JavaScript, it's usually used for the string
Inquiry.
interpolation. So
So you could use a dollar sign there if you wanted to.
I don't think you can. It's only letters and numbers and variable names. And
Oh, okay. Not like JavaScript.
yep. Let's take a 10-minute break. We made it to the end of that. We're gonna go over a couple other methods, and then we're getting it into interpolated strings and then none type. But we're actually probably gonna use most of the lecture time. Hopefully I get done with this in about 20-30 minutes after the break. But let's take a 10-minute break. I hear my dog whining. I haven't fed him yet. So we'll do that. I'm gonna pause the video. And this. All right, welcome back from the break. We're before the break, we kind of went over quite a few string methods, and there's a few more that we have. But we've gone over most of them. And we're going to go into the other methods that are more conditionals. And like we talked about with the Boolean data type, you can use these to sometimes evaluate a string before even doing something with it. Like, you don't want to waste your time trying to find something if it's not even in there, or let's say like the data isn't the right type. You can use these methods to kind of do a check on something before you do something else. So these methods really are just used to evaluate a string for certain characteristics, and they all return Booleans, but it helps. So in this first example, we have the string.isAlpha, which, just like it's in its name, it's checking to see if everything in that string is alphanumeric. So if I ran on this is my string is alpha, it's saying false. This is not an entirely alpha or alphabetic string. And why is that the case?
Because the quotation, the two quotation.
What's that?
The string, the two quotation. The spaces. The spaces.
The spaces, yes. So the spaces are characters, and they are not alphabetic. So they're not characters. So this should only contain letters. So if this was all compressed into a single with no spaces, then it would check true as is alpha. So if I put all this back and now ran it, it would come back as true. Same with using numeric. Check to see if all characters in the string are numeric and all digits. Okay. This could be useful for like a phone number if you're checking to see if somebody enters a phone number. And that's one thing you'll get exposure to in, as you're learning to code, and then you're relying on user input. Never trust a user. You always want to check all the stuff they're entering in, because they may put some wacky stuff in there. And so running these checks is important when you're writing backend code to check like for entries from users of an application. So in this case, 1, 2, 3 is numeric. If I put a letter in there, then it's false, because not all of them are numeric. So numeric strings. Remember, it's a string with numeric characters. So really, all it's checking to see if that if those characters fall in the ASCII table in certain ranges, that's what it's looking for.
Hey, Aaron, if you go back to the is alpha, and it returns a true because there's all alpha character. But if you throw a number in the middle somewhere, that's
default.
It's false.
So it needs to be not alphanumeric, but alpha.
Yeah, is alpha. Sorry, I may have said alphanumeric. This is alphanumeric here. So this is the third one. So now I have ABC 1, 2, 3. Alphanumeric is letters or digits. Alphabetic is just letters for is alpha. So is alnum is alphanumeric. I misspoke on that one. Sorry about that. But yeah. So now this one's letters and numbers, and it's also lowercase too. So that's still going to evaluate to true. But if I have a special character in there, like an ampersand or something, it will evaluate to false. And so you can also check, see if they're all lowercase or uppercase. Again, these all just return Booleans. So you can just run a check on an input string and you can get your true or false based on if it's lowercase or uppercase. In this case, because numbers can't be lowercase or uppercase, if it's in there, it just checks the ones that are actually going to be letters. So you can have special characters in here and it will evaluate all the at least letters. And if they're all the letters are lowercase, then it will evaluate to true.
Why the title is opposite? Like here, string dot is lower and you check is upper, or that just mistake?
They need to be reversed.
This is a mistake. Yep. So I can fix that.
So that's just mistake. Yeah. Okay.
Yeah. Sorry about that.
Very good.
Yeah. And so these don't really need much explanation. They're pretty self-explanatory, but you will use these in checks, for verifying like input data. That's it's a pretty important part of especially backend programming. And that's, if you get into Platoon, you'll be doing a lot of work on like backend logic or middleware logic that checks this stuff. And so you'll be using this in your functions.
So is that kind of how the whenever you're trying to create a new password and it keeps telling you that this isn't it doesn't meet all the requirements, is that what it's going through on the back end?
Yep. So basically like a password function. Yeah. So it could be in the back end, they're just checking to see if at least one item in there is uppercase or lowercase. It'll probably involve a loop over the password and then, looking at each character and then, having these as like check boxes in that loop. And if one of them is not met, then it will return a false and just return back to you that doesn't meet the criteria.
Hey, Aaron, it looks like the is upper or is lower doesn't really, it is not bothered by white space. You can include white space and it's going to still work as you want it to, correct?
Yes, yeah, like I said, special characters, because they aren't upper or lowercase, it's really going to evaluate only the letters. So
Okay. Yeah.
So if you have a requirement for only uppercase letters, but your special characters don't matter, this is a good, useful case for that. Moving on to interpolated strings. So back, in the not too distant past, we used to format strings differently. Now we can kind of inject variables into a Python string, which is super nice because it's a little more clean than using like the I haven't used it in so long. I'm trying to remember the old format. Basically you would have all of your variables at the end of the string and these like curly braces, and then you have like placeholder brackets inside your string. It looked really ugly. I didn't like it. This one's a lot easier. So in this case, I'm making a name and I'm saying Beth is a string. And what I'm doing here with the interpolated string is they're also called F strings, is you put the letter F in front of it and it will of course change like formatting for you and turn like this color depending on your IDE. And then you basically define a string. When you do that, when you use the curly braces, you can inject a variable or a conditional statement or a mathematical operation, depending on what you're doing with your string. And it will return whatever you injected. So in this case, I have greeting and I want to say Beth, hello Beth. If I want to change it to something else, all I have to do is type it into my variable name and it will change it. So this is kind of like this is the way to really write strings with dynamic content. So you'll have functions that will change things that you want to put into a final result, and you'll make an F string to do that. So when you see it, you'll see it in code. When you see that, you know that they're injecting some sort of variable in there, and so that's just a way to see different dynamic content inside of a string.
Hey, Aaron, the old method you mentioned, is that dot format?
Yes, yeah, dot format. That was it.
Okay.
Yep. Mark the F. I don't know what it stands for. A formatted string, I think, or I mean, I can take a look, but yeah, we just call them interpolated strings. It's the same.
Like in JavaScript, the $sign. What does it stand for? $sign.
The JavaScript. You talking about the JavaScript $sign?
$sign, yeah, and the curly braces.
Yeah, I mean, I don't know. Yeah, again, it's just an interpolated string. So
Yeah.
yeah, it's just a way to instantiate that type of string. So there's no difference between the two other than you can inject variables into an F string. If you have a traditional string, you'd have to use the dot format method. You still could, but this is just a cleaner way to do it. And what you'll see typically in code bases now. Moving on to escape sequences. So escape sequences allow you to include special characters. Also, you could use it to put in like a quote. If you have a single quote string, you can use escape sequence with a quote. And then your following character will be ignored by the string. The typical one you'll see a lot is a new line. So in this string here, I have a multi-line string. Now in the code, it's not multi-line, but if you see how the /n looks purple, it kind of has a different appearance. When I print it, then you see how it's a multi-line string. So this escape sequence, escape in, will cause your output to go to a new line. And you can change it to like tab. So a tab sequence, if you do it like this and you run it, now it's going to give you a tab in there. And I don't know why that one didn't do it. That's really interesting. I'll have to look into why that didn't work. But yeah, there's you can use those if you're trying to format something in a result a certain way, but you don't necessarily want to in your code have it on multiple lines. So if you have a multi-line result, but you want to still one line in your code, you can use your escape sequences with your new line.
Aaron, what if you put a space after the T on /T? That just adds a space, or is that a tab?
That was just a space. So if I pull it back, it just goes back one space.
Okay.
Yeah. Yeah, I don't know why that one is. That works. I wonder if the S in front of it is weird. Huh. Learn something new. I'm gonna have to ask or go Google that because I've never seen that before. Once you put a space between the S and the /, then it provides that tab. So
Double the tab.
So anyway. So yeah, so some of these are the most common escape sequences you'll see in code. And even then, I really don't see them very often, at least in the code bases I've been in or I've worked with, but I have seen them occasionally. So just note that / is your escape sequence, and that letter kind of gives your string it like a different behavior. And so that covers really a lot of the methods you will use with strings. There are more, some that are more complex, but for the purpose of this course, these are really all the ones you're really going to have to use. And even some of these you probably will not use. But
there's more methods, right?
What's that?
There's more methods, or that's everything?
There are plenty more methods. If you look in the Python documentation, there's plenty more. This course would be a lot longer if I were to go over all of them. So,
Man, we enjoy it, really. Yeah.
So any questions on strings before we move on to the none type?
I think everything covered. Yeah, you covered everything.
Okay. All right, the none type is pretty easy. It has one value, and that's none. And just means the absence of data. You'll see this a lot when someone's defining a variable you can use later, but they don't want it to be anything. Typically, a lot of people use empty strings, but you can use none, and it just means like absence of data. It doesn't mean zero or empty string. Those aren't equivalent. But the best way to kind of describe it is like the empty cell in a spreadsheet, right? Whereas we think of it as zero, it's not really zero, it's just nothing. And so, yeah, we find that, a lot of people in scripts will initialize a variable as none before like a script starts. And so here it even has its own type. So it's not, a string or integer or list or dictionary, it's the none type. And you can see that it's not equivalent to zero empty data structures when you run this here. When I run that, none, when I say none is equal to empty list, that's false. It's not the same thing. It's not empty string and it's not zero. So all these evaluate to false. None is its own data type. But I use it as mostly as a placeholder when I'm defining variables that are going to be used later, because you can always redefine variables. So I do that just to equate to nothing initially until the script runs. So
like accumulative variables, instead of going if value 0, we put just none.
Yeah, you can put none, and then if you need to change it later in a loop or something, you can. So I just put it there as so people understand that this is just a placeholder and it's going to be changing later. So that's my typical use for it when I'm coding. So
we assign none to the variable.
Right. So if you were to associate a variable, you would say, let's say you're like wanting to use it as a flag or something else, right? So you just like that.
Okay. I got it. That's it. Yeah. Okay.
Yep.
Yeah. That will be very useful in iteration problems.
Yeah.
Okay.
Yeah.
Thank you.
You're welcome. And so that's it. That's the end of the lesson. We explored, all the different data types that these are all native data types, which means they're not like collections or anything. These are strings, numbers, Booleans, and the none type. And so, we mostly went over the built-in string methods. Those are the ones that are, most prevalent. For numbers, we typically, for casting, we can cast them as strings. But for numbers, we typically just use them for arithmetic. And in this exercise here, we can actually try out, if we want to do this together, we can kind of try and figure out how we can use Python to calculate the cost of a restaurant bill. So let's see how we can do this using our basic data types. So using Python, how could we write a script to evaluate this input to get our expected output?
Okay.
So in this case, we probably want to
Create a
probably
variable.
want to go ahead and define these inputs, right? So we want to go ahead and just make these variables, right? So
Yeah.
bill equals 5550.
Yeah.
And then tax equals 0.0675. And then our tip equals 0.15. And so now how can we come up with the expected output based on our code here?
You can create variable, call it the total or the, give it any name, and it's equal the bill times the tax plus the tip. Here
Okay.
multiply only by 1+%.
So we'll say like you want like a total, right? So total.
Yeah.
Okay, so we'll say
Equal.
so we'll say total equals
He gives here multiply a value 1+% to get the sum of the original value plus the percent of the original value. What that mean? Because when we calculate the tax, we just multiply the tax times the bill, the value of the bill, and then we add the tip.
right. So we want to
Right.
apply the tip to the post-tax cost of the meal to get the final input, right? Or the final output.
Yeah.
Okay, so here Alexis says bill times tax equals X. So we can say total equals bill
Yeah, time
tax.
yeah
Okay.
plus
Then you would say plus.
one second, sir.
Plus 0.15. Like that.
Give me 1 second. Let me try.
Sir, do you need to put parentheses between the bill and tax just to emphasize that multiply goes first, or
Yeah,
does it already imply it already in Python?
So it'll use, so Python will work with the order of operations that you learned like in math class.
Okay.
Yeah. So it's
So so it wouldn't matter. So let's say I put the I switch the plus and the times, then it already knows what it needs to do. Is that
well,
correct? Or do
if you swap these, then it would do tax times 0.15. Then
Oh, okay, awesome. Okay,
Oh,
awesome.
no, no, no.
You answered my question.
Okay, that's not true. That when we multiply the bill times the tax, that will give you the value of the tax should be added to the bill again. So it's gonna be, you know what I mean?
So tax value,
exactly, yeah.
and then we get rid of this.
And then we make another variable.
Okay.
And I give it the name total. And it will be the tax value plus the bill plus the tip.
Like that.
Yeah. And that should give us the, let's try. No.
It looks like you're tipping
The
them.
tip is a percentage.
Yeah. Or you're tipping them 15 cents, unless you're tipping them 15 cents. Can we change line 5 to like tip rate
Yeah, we can.
and tax to tax rate?
Sure. Yeah, that will help us kind of see, that's a better, more descriptive variable, right?
And then we can say tip equals, like on line, yeah, tip equals the bill times the tip rate. So tip amount.
So then we have the total is that, right? So if I printed the total right now, that should be the total plus the tax. And then we we want to say,
After the total,
Tip.
after with the tip,
Tip
Yeah.
amount, yeah, good, equals bill times tip rate.
yeah,
total times tip rate.
Okay,
total
Right.
time tip.
yeah, yeah, you're being generous because you're tipping on the tax.
Right, that's what it said. Apply a tip to the post
Okay.
cost. Yep. So then,
Yeah. Yeah. The total tip
and then,
and total with tip, it will be the total plus the tip amount. No, not tip, not total. Total with tip, a new variable.
okay,
Tip, yeah, equal total plus the tip amount. And then we print the total with tip. It will should give us the supposed to give us the 68.13.
there we go.
Yes. Yeah, good job.
Nice. And then we could use like an interpolated string to give a prettier answer. So like I could say print, and I can do like the total cost of the meal
Yeah.
is, and then I can use a $sign, and then I can do plus string. I'm doing some stuff that you haven't seen yet, but that's, I mean, it's okay. You can still, you're getting exposed to it now. So let's see, it's total with tip, right? Tip, and then I want to round it to 2 places. And then plus. There we go.
Yeah. That's look beautiful.
Cool. And then, I mean, for these, then all I have to do is just change the values. I don't have to change anything else. I have the math already done.
Yeah.
So I can just change these. There we go. I don't have the 80, which is kind of weird, but that's a good first guess. And then, ooh, look at this expensive meal. Either a big party or a fancy restaurant. 0.0525.
And we can also change the print. We can make the interpolation, what you call interpolation method.
Oh, you want to try that? So use the F string?
Yeah. Just we delete the.
There it is.
Yeah.
Wow.
Why string? Why around? Why round? Why you don't just put the interpolation inside the print?
Actually, I don't think I need the string now because it's gonna already be cast to a string when it interpolates.
Exactly. Yeah.
There we go.
Right. Yeah. And why round, Aaron?
What's that?
Why round? Why put round?
Well, if I don't, I could do it like this, right? So I could do it like that,
Mhm.
but then I get that.
Ah, okay.
So
Yeah,
I
you do.
round it to kind of give it a more like, this looks more like a money amount versus a math amount. So
Aaron, can you put after the P and tip, or after the second brace, the closing brace, can you put a colon with a 2 F? Does that work? Colon 2F?
like right here,
Yeah.
I know that I don't think it would be here.
Oh, dot 2. It's dot 2. Colon dot 2. F.
But see, this will be in the string, so that won't show up that way. See, it's just gonna add it.
Yeah, it would have to be on the total.
Oh,
object.
inside the
Yes.
brace?
It would have to be after that, yeah.
Like that.
Like that, yeah.
Yep, that'll work too.
Because the bracket is just the bracket, it's not really doing anything. You're trying to do it with the object, not anything else.
Yeah.
There's another way to make casting, or what you call it, casting?
What was that?
There's another way to make the casting?
It's just the other way around it, really, is what it's doing there.
Yeah.
You're just adding how many significant digits after the decimal point.
Ah, okay.
Yeah.
Okay, that's good one. That's casting, right? That's kind of casting. Casting, the first method you teach us. Into
the string with the other result I had before when I put str, I was turning that number into a string so I could add it because what I was doing is concatenating the string. So if you remember in the beginning when
yeah, I'm sorry, yeah, that's my bad.
Yeah.
Okay.
When I have two strings, right? So I have string 1 equals foo, and then string 2 that's string concatenation. I can't do that before I had the result where it was just a normal string. And I couldn't do this. Right?
Yeah.
So I had to split up my string by doing this and then plus, and then I had to cast this to a string. I think it's like that. And then I actually had to have like I had to have it like this, right? And I think I can do I don't know if I can do it here. But
Outside the string, outside of the bracket.
right here.
Yeah. Yeah, that's my format is better.
Then I could always use the round function, but let's just run this how it is right now, right? So if I don't have this string here, if I don't cast it, I try and just say, well, I want to throw it in here with this. It's going to give me an error because it cannot concatenate floats to strings because this right now is a float.
Yeah. And
so I would have to cast it to a string with this method, which you see this all the time in code too. That way it knows it's been cast to a string and I can concatenate at that point. So. Awesome. Well, that's the end of the lesson. We have some additional exercise down there. And feel free to take a look at those and do those. But are there any questions on the lecture itself or anything you've done yesterday or anything interesting you found while doing some research?
Yeah, why I have a question. Why they don't put this like as a second introductory course on the website? Because the introductory course on the website is just covering the JavaScript. And it didn't cover all the aspects, like how did you cover all the more methods and more stuff we really needed in the code challenge, because I start the challenge, the code, not the code challenge. I started there's some problems you solve it in the introductory course. They didn't cover everything. They didn't cover, you need all these methods to solve this problem. So why you don't put both, one for the JavaScript and this one for the Python. So in case someone wanna feel more comfortable with this, another one more comfortable with this. And why we don't cover this aspect in the JavaScript to make it easier, you know? These methods we should use it in the JavaScript also, right?
Some of these are included with JavaScript.
If you take a look at the course, it's not like you cover more aspect, and we will need it to solve the problem.
Really?
Because I already start solving the problem. Yeah, we need everything here.
Well,
Hey.
the quick pass is a new course, and it's only over Python. So I'm not. Yeah, I really. I think the course you're talking about is the what course is it?
It's the same one like what you're doing now, but JavaScript with less.
Is it?
Hey, Aaron, I think you're probably talking about the Intro to JavaScript course that they have,
Or intro to code.
or Intro to Coding, that kind of thing.
Oh, okay.
I think a
Okay.
lot of times what was explained to me was that, because I mean, I took that course, and they said that they don't actually teach you all these, because yes, there's all kinds of methods that you can use.
Yeah.
There's all kinds of methods that you can use in JavaScript, sure, but they kind of want you to kind of do it the hard way, because we kind of get to understand what's actually happening underneath the hood.
Right.
And so they want you to use the for loops. They don't want you to use the nice, quick, easy method that, you know, Python's kind of already has a lot of built in. They want you to go through the hard stuff, really kind of do the hard learning. That way you have to look it up. You have to, it's tougher, but I know for me, it's much easier. I learned a lot more, I think, that way, that kind of method, than just having a nice, quick, easy method just to do all this work for me. So that's, I think, kind of some of the methodology and kind of maybe some of the thinking behind why that JavaScript course is kind of built the way it is than this course. So they're totally two different things.
Mm-hmm.
Yeah, but can I say something, Chad?
Yeah, go ahead.
Yeah.
In the introductory course, okay, when I start the introductory course, and after the first 2 or 3 lessons, like less than 40% of the syllabus, I start the coding problem, okay? And all the coding problems based on these methods, okay? And as someone never deal with coding or use this code or try to never learn this before, it made me really lost. It took
I
you know what I mean?
I understand where it's coming from, because I started searching up things.
To prepare yourself to the quick pass.
Yeah, I started searching up things, and I felt like I was going down a hole where not necessarily where I shouldn't be, because I was learning different things than what I needed. So I felt like I just felt more confused and overwhelmed, because I felt like I was using useless information because I didn't know what I was searching for, if that makes sense. I understand what they were trying to ask. I just didn't know how to ask it, if that makes sense, because obviously this is new to us. So I definitely understand.
Yeah, totally. And I think yeah, I totally see it. I do agree. I mean, and that's the cool thing. Like if you have maybe some suggestions or something like that, I know going through the actual the course, you know, the cohort full stack web course, every day we do you know, kind of an after action review, you know, very military, you know, what went well, what can be improved, you know, and I think they're always open for, you know, improving and I think you know, I think this quick pass is actually, you know, kind of moving towards that, kind of improving that kind of stuff. So I totally see it. I remember when I was doing it, I had already studied some JavaScript, and so I know some people that came to it having no JavaScript, it goes pretty fast. So, and I totally get that. But yeah, so I think I see what you're saying. But I think definitely, you know, any kind of feedback, and they're always looking for feedback, you know, what can be improved, you know, just respectfully let them know, hey, thanks for this, but maybe this went a little too fast for me, or maybe people should know that they should have, you know, maybe more experience when they do this kind of course, that kind of a thing. So, and they're always listening. They're always trying to improve.
I didn't say the other course is bad, but I mean, just missing more, you know, more stuff. Yeah.
So if you've taken a look at some of the resources we have in the pre-course, this is one of them for like JavaScript. So if you want to learn JavaScript on, as well as Python, this is a pretty nice, this is their legacy course. I guess they moved to legacy, but this will give you like examples of how you can nest arrays inside of other arrays in this example, and you can try out different methods in a nice REPL right here, where you don't have to, you can just code right there in your browser. This is a good way to learn the basics of JavaScript while you're learning the concepts of Python really easily. It just goes right to, give you an example, then you try and build your own. And it goes. Esteban, do you have access to material already? This stuff here?
Yes, I do.
Yeah, so right here, the links for it are all at the very bottom of that pre-course.
Oh, okay. Thank you.
Yeah, so I wanted to make sure like the pre-course is kind of for you guys to really kind of take a look at just some basic programming concepts, and then some really good links so you can kind of find your way through some of the concepts that aren't really coding related, but they're still tech related. And then it goes into like GitHub and some other, forums and practicing and stuff like that. So, and there's more we can add to this. This isn't a comprehensive list by any means, but it's a good starting point. So
Yeah, it's just my thing is just the screen is just differently on my laptop. So it's just like a different type of access. Like I'm still learning how to use the GitHub and how to function with everything.
So did you make a GitHub account?
Yes, I did.
Okay, so have you tried the GitHub code spaces yet?
I'm still trying to navigate through everything.
Okay, let me go ahead and kind of show that again, because that's like really, I found GitHub code spaces is like the perfect way to dive right in. So here we have our GitHub screen, and then I can go to code spaces here. And I've already started a couple, but I'll start another one. It's really no big deal. But I mean, it's these quick start templates. You just want to start with a blank. Like you don't need to do a Jupyter Notebook one. It's nice, but I would just do a blank template. And what it's going to do is it's going to start up a cloud container with a VS Code window already ready for you. Now it has Python, it has the other languages already kind of set in the environment, but there's no Jupyter Notebooks or anything. But if you want Jupyter Notebooks, you just go to extensions here and just type in Jupyter. And the first one here is the Jupyter Notebook support. You install that, and it will say installing. It doesn't take very long. When you get started with Jupyter Notebooks, you're done. And so it's complete now. And then you can actually take the files from the GitHub repo. So I'll go to the repo now. I think I already have it up right here, actually. Let's see. Yeah. So when you get to this is the quick pass lessons, right? So you go to this, these lessons right here. So if you want to see, like, for example, lesson 3 tomorrow, you can click on it, and then you can go to this download the raw file right here. And when you download it, it's going to go to your downloads folder, and I can open that as well. And I have it right here in my downloads folder. So let me go ahead and pull up my GitHub code spaces again. I just thought this was so cool. Like, it makes it so easy. So I want to see lesson 3 in my code space. I drag and drop it. It's going to do some download. It's going to, basically upload it to this cloud container. And now I have a functioning Jupyter notebook on my browser. I can run this on my iPad. I can run it anywhere. And it saves. So this is saved to your profile. Who was the one that put in the code spaces stuff in our chat? It was Jose. So Jose talks about it. So there's a, it's not unlimited. You get, I think it's 120 core hours or 60 core hours, something like that. Anyway, I think the lowest computing is two cores. So it's based on how many cores you have. So we get 120 core hours per month for free. So that's 60 real hours. And this course is not 60 hours long. So you can put your Jupyter notebooks in here if you don't really feel comfortable putting them on your local machine, or you can't put them on your local machine. You can put them here in your GitHub account. You have them persistent for a while. And if you really truly need to save them, you can save them. So, so that's just a way to use these Jupyter notebooks in a browser environment with no downloads at all necessary. So you can do it that way. If you have credentials, you can go through the terminal, actually do a git clone. You can clone the entire repository to yours. Or if you've already cloned it to yours, just normally, you can do that too. So we also have the lessons in HTML files and PDFs, just in case you just want to view things you don't really care about running code. You can do that too. So. Any other questions before the end of the lesson? And I'm gonna.
I have two quick questions.
Sure.
One is, in Python, are the backticks ever used for anything?
I believe so. I use them more in Markdown.
Right, or JavaScript. And the second question is, you mentioned that sometimes when you were running code, I guess as a beginner, and you would declare variables that you wouldn't use. Does a linter catch that for you, like a pylint, or does it have to be configured to catch that kind of thing for you?
Yes. So you can run like Pylint or something else, and when you like save your code or you run your code, it'll give you like a warning. It'll say, "Hey, this variable's unused."
Okay.
And also just the linter itself. Like, let's say, for example, I have my just drink rate, right? So if I recreate here equals or just drinks equals I don't know, 10. Here it's not doing it, but like I know on some IDEs, like if you define a variable, but you don't ever use it anywhere, it'll like gray it out kind of, or just make it a little more muted.
Okay.
It hasn't been used. So that's like in a standard Python file.
Thank you.
Yep.
I have a question. I didn't get the question, Michael question about the backticks. Do we use the backticks for anything else more than the making strings?
Let's look it up. Right.
Is this what you meant, Michael?
Yeah, you know how in JavaScript we can use backticks for strings, just like single quotes and double quotes, and I'm curious if backticks are used at all in Python for anything.
Because I know it's just for strings, but
so in this, I mean, I don't think they are, because I really haven't used them. But here's a stack. I just Googled backticks in Python, and then and this is 14 years ago. So this is a pretty old answer, but they basically backticks are a deprecated alias for the repr, which is like a string representation. It's a class method, but it's deprecated and it's not used anymore.
Okay, thank you.
Yep. And so I'm gonna try and get it posted tonight. I'm trying a new method of posting YouTube videos that the instruction team came up with that like utilizes AI. It's kind of cool. So I'm gonna try and use it. We'll see if it works. If not, I'll post it manually, but I'm gonna try and run the script tonight. So
Thank you for being patient.
of course.
Thank you very much.
I don't think I'm being patient, I'm just answering questions.
No, we ask a lot.
No, it's good. If you're
Yeah, but
asking questions, it means you're learning, right?
Yeah, exactly. Yeah, yeah.